Hey there! In this lesson we are going to create this cool effect. It's a burning rose with fire, glowing embers, and some awesome smoke. The lesson is split into 8 chapters. And at the end there is a little bonus. I'll show you some behind the scenes from the final shot I made using the rose. Let's take a look.
Like everyone else, you want to learn the way to win, but never to accept the way to lose, to accept defeat. To learn to die is to be liberated from it. So when tomorrow comes, you must free your ambitious mind and learn the art of dying.
Before we begin, it's important to mention a few add-ons I'll be using for the project. Also, I'll be using the Pie menu a lot. To enable it, go into your preferences, open the Came-up section and check this box right here. Let me quickly show you a comparison between Embergen and Mantaflow. Here is a comparison chart, and honestly, it speaks for itself. Alright, let's get started. First, let's load in our model. I found this rose on Sketchfab and the author goes by the name Lollipop. Huge thanks to him. Download the FBX format and let's import it into Blender. Before we move on, let's set up the project. I'm working in 30 FPS with Full HD resolution. Project is made in Blender version 4.3.2. Okay, let's bring in the FBX file and open it up. When you import it, you'll see a bunch of separate pieces. First, let's just move the old things up a bit, like this. Then we need to merge all the parts into one mesh. Let's give it a proper name. And now I'll set the object's pivot point to the base of the model. Now, to make the rose look a bit more interesting, not so perfectly straight, I want to rotate it slightly, maybe around 10 degrees. Then I'll reset all the transform values to 0 using Ctrl-A, apply all transforms. Let's also create a basic material right away, something bright so we can easily see it. I'll delete the default material, make a bright red one and see how it looks. So here is the plan. First, we need to optimize the model. Right now it's way too detailed for simulations and animation, so we will create a proxy mesh, a simplified version of the model. That way we can work faster and run more tests without waiting forever. Let's start with the first proxy. This is one will be used for rigging. I'm removing the material from it so I can tell the difference. Red means the main model and the white will be the proxy. Alright, let's make a basic sphere. This sphere will represent the top part of the rose. In our proxy version, we are kind of building a rough box version of the shape. Switch to sculpt mode and using the grab brush, I'll tweak the sphere a bit, like this. And my goal here is to completely enclose the top of the rose inside the sphere-like shape. Next I switch to object mode and I add a boolean modifier to combine the sphere with the rest of the model. Let's hide the main mesh for now. Then go ahead and apply the modifier. If you don't see the apply button, just make sure you enable the modifier tools add-on in your preferences. Now let's delete the ecosphere, we don't need it anymore. Let's go into edit mode and take a closer look. Press M and use merge by distance to clean up any unnecessary vertices. Now let's simplify the mesh a bit. First we'll add a solidify modifier to give it some thickness. As you can see, the main model now fits completely inside the proxy mesh. That's exactly what we want. Still, I need a bit of cleanup. Next, we'll use the remesh modifier to make the shape even simpler. Let's turn that on. I'll tweak the remesh setting here until it looks right. When we switch back to object mode and apply all the modifiers. Now let's go into sculpt mode. Grab the grab brush and start shaping the proxy so that it fully covers the main model inside. I'm doing it in sculpt mode because it's fast and really easy to adjust things with brushes. Once you're done sculpting, switch back to edit mode and again hit M, merge by distance, to clean up the mesh. Now I'm going to use the 3D print add-on to check that our mesh is completely closed and manifold, ready for rigging or simulation. And that's what our rigging proxy looks like at this point. Let's hide it for now and see what we've got. Next, let's create a proxy for Embergen. We'll need this later on. Just duplicate the main model and name it something like proxy simulation. Let's remove the red material from it as well. Then using the solidify modifier, we'll add some thickness to the model. Now let's apply a remesh modifier to simplify the geometry. This way it works much faster inside Embergen. I'll tweak the values here until it looks good. And this is what I end up with. Again, I press M, merge by distance to get rid of any extra points. In edit mode, I select all the polygons and then use the 3D print add-on again to make sure this version is also manifold, nice and clean. Now I am going to assign a different material to this simulation proxy. I'll make it green, just to help me visually organize everything in the viewport. This way I can quickly tell which model belongs to which part of the project. Let's also create a new collection and name it proxy. Keep things organized. Alright, now let's get into rigging. This is our rigging proxy, ready to go. I'll switch to wireframe mode so I can see the topology better. If you're wondering why my wireframe looks like this, Here are the settings I use. Alright, let's get started with the rig. We'll begin by adding an armature. Let's go into the armature setting and turn on the option that makes it always show in front of the mesh. There is also this button here. It turns on X-ray view. Move the first bone into position, right around here at the base of the model. We need to duplicate the bone. Just press E button and move it up. We are basically following the shape of the stem, and then we will move up towards the top of the mesh. Let's check how it looks from the back. We need to make sure the bones stay inside the model. So I'll move a few of them slightly, like this. Now it's really important to give your bones proper names. So I'll go ahead and name them in a way that makes sense. Next, we'll add bones for the leaves. We'll adjust the position to match the shape of the leaves. And again, naming matters. Let's name them properly. I'm calling this one leaf R. The R stands for right side. And I'll do the same thing now for the left leaf. Just adjusting the bones a bit to fit nicely. That part is really important. Alright, everything's named. Let's switch to object mode. First select the mesh, while holding shift select the armature. Now press Ctrl P and choose with automatic weights. Then switch to pose mode. The basic rig is working. And yeah, this is exactly what we want. But let's make this even better. Go into object mode, select the model and you'll see the vertex weight group. Now select the model and switch to weight paint mode. Here we can smooth out the transitions between the bones using the blue brush. I'll just brush over the edges a bit and as you can see, the transitions become much softer. This is exactly what we want. Now let's go back to object mode. We'll hide the mesh for now, we don't need it, and focus on the animation. What we want is to create this gentle swaying motion like the flower is moving in the wind. Let's make that happen. Select the first bone. Then press Ctrl-Shift-C and add a child of constraint. We are going to create a controller for this bone, so we can animate it easily later on. Let's scale down the controller to around 5 or 6 centimeters, just enough to keep things clean in the viewport. I'll make it a bit smaller and rename it right away something like C for controller. Let's also create a new collection for our controllers, because we'll have a few of them and we want to stay organized. Now we are ready to add more. Switch to pose mode, select the next bone and again press Ctrl-Shift-C and add another child of constraint. You get the idea. We will repeat this process for all the bones we want to animate with controllers. Everything's working great. Now let's head over the graph editor. Select the first controller, press N to open the properties panel and we'll animate the rotation on the Y axis. Hover over the Y rotation field, then press I to insert keyframes. Now let's add a noise modifier to the Y rotation curve. This will automatically generate some random animation. We just need to adjust a few settings. Scale controls how fast the motion is, and strength controls how intense the movement is. Now let's do the same thing for the next controller, but with slightly different values. That way the animation feels more natural and less repetitive. Let's keep going and add motion to the rest of the controllers. Let's add another effect. Pressing Ctrl-Shift-C, and this time I'm adding a damped track constraint. As you can see, the animation has a slight delay, like the wind is gradually fading out. It's super important to animate the influence, especially at the beginning. At frame 1 we want the effect to have zero influence, because we need the proxy mesh to match the position of the main object exactly at the start. At frame 40 we'll gradually bring the effect in, so it fades in slowly. Let's do the same thing for the left sleeve. 0 at frame 1 and then gradually up by frame 40. Now let's do the same thing for the noise modifier on the rotation. We want to make sure that at the beginning none of these effects are active, so the proxy mesh stays perfectly in sync with the main model. These are the settings I'm using here. The key point is, at the start of the animation everything should have zero influence. You can also experiment by adding noise to other rotation axes if you think it makes the motion more interesting. I actually keep it simple, mostly on the Y axis and maybe a little on the Z axis for some subtle variation at the top. As you can see, at one point I made a mistake and you'll notice the animation doesn't fully return to 0 at the beginning. I can show you how to fix it. Also, I noticed that my proxy isn't fully covering the main mesh. So let's go into sculpt mode and adjust it a bit. Now let's move on to applying the effect to the main model. on the row's main object, we are going to add a mesh deform modifier. And for the object, we will choose our proxy rig. Before you hit bind, make sure to save your project. Hit bind. It will take a bit of time, and when it's done, the proxy will start affecting the animation of our main model. We are getting these weird artifacts. Let's turn off the effect by pressing unbind. Then bring back the proxy rig and go into sculpt mode to fix the areas that didn't fully enclose the main mesh. We need to make sure the proxy covers the entire model, no gaps. Once that's done, save the project again and hit bind. Now let's see what we've got. Yeah, now it works perfectly. No artifacts, and the proxy is smoothly deforming our main model. Next, we are going to apply the animation we create to the proxy simulation mesh. Same process, add a mesh deformer modifier, select the proxy rig as the object. Okay, now I noticed that the simulation proxy isn't fully covered by the rig proxy. Let's go back and tweak that so everything fits properly. Once the fix is done, hit bind again. And now everything works as it should. No glitches, no artifacts. Let's save the project one more time, and congratulations, we finished setting up the rig and animation for the flower. Go into edit mode, select the entire mesh and create a new vertex group. Give it a clear name. I'll call mine mask, and don't forget to hit assign. To create the mask, I'll use a simple grid object. And I'll add a few extra subdivisions to give us more detail to work with. Let's go into edit mode and start shaping our mask a bit. Right now it's completely flat, so let's add a displacer modifier. And use a cloud's noise texture to give it some variation. We will tweak the settings to make it more subtle. We don't want the displacement to be too strong. To make sure the pivot point is centered on the mask, go to Object, Set Origin to Geometry. And that's it. This will be our texture transitioned mask. Now let's switch over the shader editor and select the main model. At this stage, we are only focusing on the material output, so keep things simple. Add a texture coordinate node, and for the object input, choose our mask object. Next, we will add a gradient texture, a mapping node, and connect everything up. Let's adjust the rotation so the gradient moves in the right direction. The mask is too soft right now, so let's add a color ramp to sharpen it up. Here's what we get, and we'll keep refining it. We will add a noise texture and blend it using mix node. Now we can go in and refine the gradient fell off. By the way, quick reminder, all the shader node screenshots are included in the project folder. You will find the download link for that in the video description. We are getting these rough, irregular edges, and that's exactly what we want. Time to test the mask, and yes, it's working. The edges are nice and uneven. Now let's animate the mask so we get a transition from black to white. In some places I'll pause the motion briefly, and where the white appears, that's where our burning effect will happen. This is the animated mask I ended up with. Let's check it out. Looks pretty good. It feels natural, not too linear, and we will keep building on top of that. Now let's figure out the plan for the shader. First we need the main mask for the transition. We already made that. Next we will create a separate edge mask to add that glowing burn line. We will also throw in some blue highlight details, and later we will animate some sparks and embers inside the material. Let's split the screen and start working on the material setup. Here we still have the mask system we built in the previous chapter. To keep things clean, I'll create a frame and start organizing the logic of our shader. Let's move the material output to a separate spot. I'm picking a green color for all my mask nodes. Let's duplicate the main mask. Now we need to build the edge transition, the boundary between the burning area and the untouched flower. Using the color ramp, we'll add a black point just before the white. Next, let's bring in the texture maps that came with the Rose model. We will plug them into the principled BSDF shader. Also connect the rest of the textures to their correct slots: normal, roughness, and displacement. The displacement looks a bit too strong right now, so let's tone that down. Now let's do a test render to see how it's coming together. I'm going to add a light source using the Light Wrangler add-on. It's super handy for quick lighting setup. I'm also darkening the background a bit just to better isolate the flower. Let's get rid of any extra stuff like the grid and maybe add another light for more depth. Now I'll name and organize the shader inside the project. And here is an important step. I'll increase the subsurface scattering weight to 1 and set the scale to around 20 centimeters. Let's add an HDRI environment map, just to give it a bit more ambient lighting. In this setup I want the HDRI to light the scene, but I don't want it to be visible in the background. To do that, I'll use a mix shader and plug in the light path node as the factor. Now the background stays dark, but the HDRI is still lighting the scene. Here is how it looks without HDRI, and here is how it looks with it. Now let's add a texture for the embers. I'm going to use a promade shader for that. Let's start by adding a cube. I'm using Blender Kit add-on, it's free, and I'll search for this specific texture. We'll just copy the shader nodes from it. Then I'll select the rose model, hit Ctrl V, and paste those nodes into our main shader. Let's give this group a clear name and organize it. The cube isn't needed anymore. This is what it looks like so far. I'll test using object coordinates first, but later I'll probably switch to UV mapping. To control the scale, I'll add a value node. Let's start refining the ember shader. First I'll add a noise texture and adjust the settings. Now let's add a color ramp so we can clearly see the gradient. I'll set the noise texture to 4D, which allows for animation over time. Next I'm going to split the screen and bring in a color palette I created in Adobe Color. I'll be using these stones for the glowing embers. I'll also add a value node and connect it to the W input of this noise. This will drive the animation. We will use a small expression to animate it. The higher the number after the slash, the slower the movement will be. Right now it's moving way too fast, so I'll lower the speed. I'll type in some beta values and leave it like this for now, since I'm preparing for a test render. Let's add another noise texture. This one should be slightly larger to add some variety and break up the pattern. Let's tweak it a little. We will also connect a value node to its W input and use the same animation expression. Now let's combine both noise textures into a single factor. Let's also switch to a different noise type and do a little fine-tuning. It's all about experimenting and it takes time, so during editing I'll speed up a lot of this process. Now let's add an emission shader and preview how everything looks. Let's select all the related nodes and organize them a bit. Now let's start working on a new mask. Connect the mix shader to the material output, and here is what we get so far. It still needs work, but I think the basic idea is already coming together. Next, I want to add blue accents to the ember texture. All the node setups are saved in the project folder. You will find the download link in the description. Now I'm fine-tuning the blue highlights in the texture. I also want a bit more control over the mask. So I connected a mapping node. I'm working on small details now, just polishing things. This is what it looks like. We will just need to swap the shader inputs to make sure the transition is happening the right way. Yes, now it's correct. Here is how the blend looks. We got it working. Next, let's add another mix shader. Now the edges of the gradient are brighter, which makes sense since that's where the temperature is highest. And the best part, we can control the mask animation using the drivers and controllers we already set up. I ran a test render and here is how it looks. Right away I noticed a couple of problems. The sparks animation is moving too fast, and there are some artifacts on the model, weird lines, probably caused by the displacement map. So I'll need to fix that and also tweak the brightness and shape of the spark pattern. First, I'll reduce the displacement strength a bit and check the result. Yes, much better now. Next, I'll adjust the embers. Scale them down slightly and increase their brightness in some areas. To slow down the animation, I'll increase the value of our driver expression from around 8000 to 10,000. That should calm it down a bit. Now I'm recognizing the shader network and running another test. Even with that adjustment, it's still moving too fast in my opinion, so I'm pushing the value up to 12,000. That's a big number, but in this case I don't want the sparks moving quickly. Also, I'll increase the normal map strength on the flower material just a little for a bit more surface detail. I'm previewing everything in cycles, but doing the actual test renders in Eevee. It's way faster for this kind of work. Here's what the final material setup looks like. We are going to do this in Embergen. But first we need to export our simulation proxy from Blender, and we will export it as an Alembic file. Set the scale factor to 50, and most importantly, the frame rate must be 30 FPS, match it exactly. Now let's prepare a mask for Embergen. We need to make it a bit thicker first. I'll use a solidify modifier with these settings here. Then we will export this mask as an Alembic file. The same export settings we used before. Alright, now we're in Embergen. Let's open the presets tab and search for a good smoke preset. There is one called Wispy Smoke and it works great for what we need. Let's use that as our starting point. First, let's clean up this scene, move things around and get rid of anything we don't need. Now let's import our proxy mesh. If you need help navigating in Embergen, Here are a few hotkeys on screen. Now inside the mesh setting, it's really important to check the box for override FPS. Set it to 30 FPS, the original frame rate from Blender. Let's go into the simulation node and adjust the container size, because right now it's overlapping our mesh. Let's also set upscaling to none for now. That will keep things running faster while we work. We will also delete this default primitive, we don't need it. Now here is our main object. Let's do a quick test to see how things are working. Okay, it works, but there is a problem. The smoke is emitting from the entire mesh. Right now, if we leave it like this, fire and smoke will be generated from the whole mesh. But remember, we have a mask object. The goal is to make fire and smoke emit only where the mask intersects the mesh, basically at the edge of the burning area. Let's bring that in. Import the mask alembic file. And fast quick tip, if you ever looking for hotkeys in Embergen, they usually show up right here on screen. Back to the mask setup. Don't forget to enable override FPS again and set it to 30, just like before. Now let's blend the two shapes together. We will use a shape blend node, and this will let us emit from the intersection between the mesh and the mask. Let's hide the mask object and see what we've got. Visually nothing seems to change right away, it's not very obvious at first. I'll increase the fill rate all the way up to 1000. That's push more smoke into the seam and make things more visible. Now we can see the fire and it looks like our emitter is working properly. Let's go back to the simulation node and take a look at the upscaling settings. If you choose factor x2, that means the simulation resolution will be doubled. Much higher quality, but it will also run slower. We can see a lot more details in the smoke. We will jump into the forces panel and tune the noise settings. Right now I'm just experimenting with different settings to see what gives the best result. This controls the number of vortex stands. I'll try reducing the number a bit to see how it affects the overall look of the simulation. Another critical setting is buoyancy. This has a big impact on the look and feel of your sim. Let's set it to 10. This controls the strength and speed of the upward motion that pushes the fire and smoke into the air. Now let's move over the volume processing panel. There are some key settings here that heavily influence the look of both fire and smoke. Definitely take time to experiment with this, they make a huge difference. Back in the emitter, I think we need more fire overall, it feels a little too weak. I'll bump the flame intensity up to 1500. Feel free to experiment with this as well, it's one of the most important parameters for getting the look just right. One cool trick, you can randomize the look of the simulation by changing the force seat. there is just too much smoke. Let's just adjust how quickly the smoke disappears. There is a setting for that. If we set up it to 100, the smoke disappears instantly. At 50, the smoke will fade out after about 1 second. Let's try 75. That feels just right to me. I'll leave it there. Next, I want to increase the fuel rate to get even more fire into the simulation. Let's see how that looks now. I think better. Now I want the smoke to fully disappear at the end of the animation. We will animate the smoke dissipation. The idea is to make the smoke fade out smoothly towards the end. Here I made a small mistake. I set the value to 0 at the end, but it should actually be 100. Just remember, 100 means no smoke at all. I'll fix that a bit later in the video, but I'll leave the mistake in so you can see how it behaves. And now let's export the simulation as VDB files. We will connect the output from the volume processing node into the export VDB node. In this case, my animation has 720 frames. I'll keep this. Now pay attention to this setting, frame stride. I found a tip in the Embergen Discord, and here is how it works. Our animation is 30 FPS and the time step in Embergen is set to 60. That means we're generating twice as many frames as we actually need. To fix this, we set frame stride to 2. That will skip every second frame and give us the correct total. Also, we need only 2 channels for use in Blender, density and flames. That's all we need. The rest of the settings can stay in their default values. Now let's go back to the simulation panel. We need to set the upscaling to a higher value for better quality. In my case, X2 worked fine. Export your entire simulation. And that's it for Embergen. Press Shift A and add an open VDB object to import the simulation. Press A to select all them and click Import. So now we need to scale the VDB objects down by a factor of 50. Just go to the value settings and divide all values by 50. Now the smoke looks properly aligned. Let's see how it looks so far. Yes, we can see the smoke, but we will need to add fire manually in the shader. Select the VDB object and add a new shader. The fire channel in Embergen is called Flames. In the shader, let's change temperature to Flames. Set the temperature to something like 10,000 K, and yes, now we can see the fire. Now let's add light that affects only the smoke. This can really help separate the elements visually. If you work in an Eevee, there are a few things to tweak. Increase the sample count for better smoke visibility. In the volume settings, set the step rate to 1:1 for full resolution quality. This is how the final simulation looks inside Blender. In cycles, the result looks much better in terms of realism. but Eevee gives us faster previews while we work. I experimented with different temperature values. Now let's talk about cycles settings when working with smoke and fire. There are the values I personally use. They work well for this type of simulation. One last thing that's really important: clamping. If you are seeing weird artifacts or flickering in the render, clamping can help. I've prepared a small chart with recommended clamping values. Let's use those values. They will help keep the render clean and controlled. Now I am running a test render with denoising turned on. Now I'll switch over to Eevee just to see how things look there. There are the settings I'm using for Eevee. I want to do a test animation to make sure everything runs smoothly. So I render a quick preview, and here is how it looks in Eevee. Now we are going to add particles. Let's start by using up the emitter. We will duplicate the mask object, clean it up by deleting any extra frames, and set it up to follow the original mask using a constraint. Let's name this object Particles Mask. I'll also adjust its transform orientation a little to make things look more accurate, and raise it slightly in space so it sits better. Now we have a mask object for particles, and it's perfectly synced with the motion of our main mask. Next we will duplicate the proxy simulation mesh and call this new one proxy particles. Switch to edit mode and let's add a vertex group, because the mask will be based on vertex proximity. Now comes a really important step. We will add a vertex weight proximity modifier. Set the target to our particles mask object and assign it to the vertex group. Now take a look. The blue areas are where particles will appear. I'll fine-tune this mask a bit more. So far, it's working as expected. Now we will add a mask modifier and point it to the same vertex group. This gives us full control. Re-enable the main model so we can preview how the texture and masks are lining up. We will switch to viewport view and refine the particles mask. It's still a bit too thin. Now that mesh looks good, I am happy with how the mask is behaving. Let's clean up the project a bit. We'll organize everything into collection. Now we can move on to the particles setup. Let's add an emitter object. Right now it just looks like a cube, but don't worry, we will fix that. Switch to the geometry nodes editor, start building the system, and let's begin setting up our particles. To start, we will create a simulation island using geometry nodes. Now we are going to use nodes from an add-on called ProParticles. It's available on Blender Market. Let me walk you through a basic setup. This is how most simulations begin when using this add-on. We add an emitter when set a few standard properties: lifetime of the particles, radius, velocity. Now for the emitter object we will choose our proxy particles mesh. And very important, don't forget, set the end emission frame to 360. Here's how it looks so far. It's still a bit rough, but don't worry, we will just get started. Adjust the radius, make the particles smaller. Lower the velocity down to 1 to reduce their speed. Right now these particles are just virtual spheres, placeholders points in the scene. Let's set the lifetime. Now I'll add a change radius node. This makes the particles start at size 0, grow slightly, then shrink back down to 0 at the end of their life. Let's run a quick test to check if everything's syncing up. Still needs work, but we are on the right track. Now let's add a bit of turbulence on the simulation. We will tweak the turbulence setting to add some randomness to the motion. Now let's create a new scene. This is where we will build the actual mesh for the particles. We'll use a simple plane and apply the same texture we used earlier in our shader setup. Let's apply that material to the plane and switch to viewport render so we can see the result in real time. Next we need to select a good looking piece of the texture. Let's go into edit mode and we will use the knife tool to cut it out. Press K and use the knife tool to cut out the shapes you want. Select all the cut out pieces. While still in edit mode, press P and choose separate by loose parts. Now we need to set the pivot point for each piece correctly. Select each piece, go to Object, Set Origin, Origin to Geometry. Then press Shift S and choose Selection to Cursor. That centers all the pieces in the scene. Let's go ahead and name these objects properly. Next I'll duplicate one. I want to create two sparks, one red and one orange. For the sparks object we will remove the material. This will be a very simple emission shader. That's our first spark. Now let's duplicate it and create a second spark, this time in orange. Let's group everything into a collection. Then copy that collection, switch to main scene and paste it in. These objects will now be used as particles instances. Let's go back to the particle emitter setup. Make sure we are working inside geometry nodes. Add an particles instance node and connect it here. Then in the instance setting, select the collection with our particles. Here is the copy of the collection. Right now we can't see much because the scale is too small. Let's fix that. Let's also add a bit of random rotation to the instances, just to break up the pattern. Some of the particles seem to disappear instantly, they don't scale down to 0, they just vanish. So we will need to fix the scaling animation, make sure the radius starts at 0, grows a bit, and then goes back to 0 at the end of the particle's life. I'm testing and adjusting everything, just trying different settings to see what looks best. This is definitely a creative process and it takes a bit of time. I'm constantly tweaking things and seeing how they behave. And by the way, the exact particle settings, including the node setup, are saved as screenshot in the proper files. Here is the final particle setup looks like. Now let's see how it all works together with the fire and smoke simulation. I ran a test render and here is the result. And congratulations, you made it all the way through and created this burning flower effect. In the last part of the video I want to show you a little behind the scenes time-lapse of how I built the desert flower scene. This will be a speed up, not a full tutorial. Otherwise, the whole video should run close to 3 hours and that's not what I want. To start, I created a large plane for the terrain. Added displacement and adjusted the shape to get some natural hills and bumps. Then using Blender Kit I brought a rock model. I scaled it, rotated and added a cube to cut a hole in the rock. That's where the flower would grow from. Next, I tweaked the terrain a bit more, changing the height of the plane. At first I used dolly rig for the camera, but I ended up removing it. The scene was so simple that I didn't really need a rig. Then through Blender Kit again I found a grass model I liked and moved it outside the camera view, just in case I'd use it later. After that, I found a few branch models. I used the distribute points on the faces node to scatter the grass and branches. I also added random rotation and scale to each element just to avoid that copy-paste look. For the branches, I played around with the seed value and used density to control how many were scattered. The background is just a simple plane, nothing fancy. At this stage I started adding lighting because now it made sense to work on shading. In the background I used an emission shader to create soft ambient light. At first I tried using a preset sand material, but it rendered too slowly, so I replaced it with something simpler. Then I used area light to create highlights and focus points in the scene. You can experiment with this. Using light linking, I was able to control which light affects which object, which helped me a lot. For example, I made one light affect only the sand. This gave me more control over the model mood and helped separate the scene visually. Another light in the scene is set to affect only the rock, and one more, very importantly, affect only the smoke. This is crucial because if all lights affect everything, some objects end up overexposed and the whole scene looks blown out or unrealistic. At this point I wanted to add a bit of animation to the grass so it looks like it's swaying in the wind. To do that I used a displacement modifier. It's a fully procedural setup. I did this part in a separated scene just to keep things faster and more responsive. Then I applied the same modifier to the second grass model and it worked out well. Now I'm tweaking the sand material. I realized I wasn't happy with the preset shader I had been using. Just a simple principled BSDF. And here is an important detail, don't forget to add subsurface scattering to your sand shader, it really helps it look more realistic. This gave me a much better result and what's more important, it works faster. Later on I added even more detail with a bit of bump and displacement. I also noticed there were some distracting objects in the background near the flower, so I removed them to clean up the composition. The light setup I used here, for example, having a light affect only the rock, adds visual contrast and makes the scene more interesting. Now I've turned on the fire and particles to see how everything looks together. And again, I made sure only one light is affecting the smoke, so it doesn't get too bright or washed out. And that's the final result. Thank you so much for watching. This was a long one, but I hope it was valuable for you.
Like everyone else, you want to learn the way to win, but never to accept the way to lose, to accept defeat. To learn to die is to be liberated from it. So when tomorrow comes, you must free your ambitious mind and learn the art of dying.
If you enjoyed this tutorial, make sure to subscribe so you don't miss the upcoming videos. Thank you for your attention and see you later.